Okay, question 23. We're given a speed distance graph for a car's journey below, and we're asked to estimate the acceleration, and then it says estimate the average speed. Okay, so what we should know is that with a speed time graph like this, the acceleration is given by the gradient, and the area underneath the curve gives you the distance. Those are facts that you might need to revise. So, if we start off with the acceleration, it says estimate the acceleration at 6 seconds. So all we have to do is draw a tangent, a line that just touches the curve, at 6 seconds here, and then we work out the gradient of it. Okay. Now this is a bit tricky because obviously, at 6 you could there's arguably quite a few different ways you could draw the line. So, I think what I would do is follow the line up with my ruler, bending it round to give the same gradient as each point of the line. And I want 6, which is this bit here, look. So I'm looking to get up to this bit. So I'm just making my ruler fit that line. And 6, look, is about here. So, this is why it's important to take pride in your work to do this properly. Alright, we don't want to just guess at it. And I'm going to draw my line like this. Okay, I want to find the gradient of this line. And to find the gradient, I need to do rise over run. So that basically means if I draw a triangle, I'm going to look at how high up I've gone divided by how far along I've gone, and that will tell me my gradient. Okay, so if I read the scale, I can see that with 5 tiny squares it goes up in 2s. So 2 divided by 5 is 0.4, which means that every square is worth 0.4, and that's the same up this side as well. So it's going to be 0.4, 0.8, 1.2, 1.6 and 2. Okay, so I need to remember that when I'm counting my squares. Now in terms of where I'm going to draw my triangle, it's important that you draw it so the line cuts through cleanly at the square. So for example, I wouldn't start drawing it here, look, because I don't really know how much of a square that is. So for example, this bit is quite good because it goes right through the top of that square, and if I go down, I'm going to look for a point where it cuts through nicely. Let's see if we can get a better point. So maybe that's probably the best point, really. It cuts through there, look. So we're going to draw a triangle like this, and we want to go up to this point here. I think that was what I just said, or maybe not, maybe. Right, so let's mark on a point. Actually, I'm going to pick on this point here because that looks good, and I'm going to go and pick on this point here. I'm looking through where it cuts through a whole square, so I can just make it easier for myself when I'm working out the gradient. So I'm now draw my triangle. I might do this in colour just to show this a bit clearly. Okay, again, take pride in your work, do this neatly, use a ruler. Okay, I don't want to give the examiner any excuse to knock me any marks. So I know each square is worth 0.4, so counting up in 0.4s, 4, 8, 12, 16, 20, 24, 28, 32, so that's 3.2. And going along here, I've got 4, 8, 12, 16, 20, 4, 8, 32, 36, 40. Okay, so I can see that is 4.0. Alright, and now using my formula, rise over run, I can see that my rise has gone up by 3.2, my run is 4. So 3.2 divided by 4, and working that out gives me 0.8. Okay, so my acceleration at 6 seconds is 0.8 meters squared. Now if we look at the mark scheme, this is quite interesting. We're told we get a mark for drawing our tangent at 6, which is that straight line at 6. We get 1 mark for calculating the change in speed divided by the change in time. Now remember, the speed was this vertical axis here, so that's the rise bit, and the time is the run. So if we've done the rise over run part on the tangent, we get a 2nd mark. And then it just says correct answer for their tangent. They have given you absolutely no guidelines whatsoever what the final answer should be, okay? Because obviously drawing a tangent is quite difficult. There's lots of different ways I could draw that. Some people might disagree with me the way I've drawn this. They might say it should be less steep or steeper. And also counting the squares. If I did this again, did a bigger triangle, just because it's difficult counting the squares, I probably would get a different answer next time. So as long as you've done it correctly according to your tangent, that's why it needs to be really accurate and done properly, then you'll get the marks. Okay, so the next part of the question then says, estimate the average speed of the journey. And if we think about speed, distance, time, so one of the compound measures that we should know is my triangle for speed, distance, time. We can see that the average speed is going to be distance divided by time. Okay, so I'm going to write that down so I don't forget. And basically the difficult bit is we need to work out the distance. Okay, and like I said a minute ago, the area underneath this is the distance. Okay, because we've got this whole ball curve, we're going to estimate the distance using a ruler and by splitting this up into parts. So I'm going to get my ruler out and I'm going to split this up. I'm going to draw a triangle here, look. Okay, so if I work out the area of that triangle, that roughly estimates the area underneath this bit. And then the next this bit I chose because I can see that it goes through the top of this square, so that makes a nice triangle. The next bit, some people, when I mark the questions, we're doing shapes like this, but don't really create more work than you need to. And the next sensible point is at the top of this square here, so I'm going to draw that. Then we've got the next point here. I'm going to draw a rectangle connecting that, and then finally we've got the triangle. So I've split my area into 1, 2, 3, 4 shapes. I'm going to work out the area of each of them, add them all up, and then that'll give me my distance. So triangle, base times height, then divide by 2. So 4 times 6 is 24. Half of 24 is 12. Note this on here, and then I'm going to show my working in a minute. Now this next shape, if I just draw this up actually. Okay, my next shape is actually a trapezium. Alright, it might be easier to turn the page around like that to see this. But a trapezium is a 4-sided shape where we have 1 pair of parallel sides and 1 pair that aren't parallel. And to find the area of a trapezium, we can half the sum of the parallel sides. So if we look here, this is 6 and this is 12. The sum of the parallel sides is 18. Half the sum of the parallel sides is half of 18, which is 9. And then you need to multiply it by the distance between them, which is this distance. So 2, 4, 6, 8, 10. So I'm doing 9 times 10, which is 90. So my next part, I'm doing 4 times 12. So 4 12s are 48. And for my next part, I'm doing 6 times 12 and then half it. So that would give me 36. Okay, and then I just need to add them together to give me my total distance. Okay, so I get 186 which is my total distance. And note that down on there. Now the examiner's not going to be too happy with me if I do that, so I need to do need to show some work. It does clearly say that as well. So we can say that the what actually might be quite good, to be honest, is to label these. So if I label that A, B, C, D, then in my working it's shown nice and clearly, so I can say that A equals this and so on. So A equals, so I did 4 times 6 divided by 2, which was 12. Then B equals half of A plus B, using the trapezium formula, multiplied by the distance between them, which I said was 10, and that gave me 90. I'm going to circle these, so I know to add them in a minute. For C, I did 4 times 12, which was 48. For D, I then did 6 times 12, and then don't forget to half it, which was 36. And then adding them together, so 12 plus 90 plus 48 plus 36, then gives me 186. Okay, now this is my distance, and if we look at it, it is m/s, which is meters per second, so this answer is in meters. But remember, that's not our final answer, because it says estimate the average speed, and we know that speed is distance divided by time. So if we look at this graph, it goes up to 24, and that's 24 seconds, so our time is 24. So we now need to just put this into the formula. So we know that speed equals distance divided by time, which is 186 divided by 24. So putting that into my calculator gives me 7.75. So that's going to be my answer. Okay, again, checking the mark scheme. It says if you attempt to work out the area below the straight lines, so this bit, then you get 1 mark. Notice it says an attempt, so if you did 4 times 12 but then you put the answer wrong, you still get the mark, but you do need to say this 4 times 12 bit, or if you just said 48, you get the mark. The second bit, attempts to work out the estimate under the curve. So this is the curve bit here, so I would need to do that bit, add that bit. That's my area under the curve. And that gives you the second mark. Whatever your total distance was, if you divide it by 24, you get the third mark. And then it says their answer worked out correctly with no errors in area below the straight lines to get the fourth mark. And it also says the area must be in the range of 168 to 196. So if you've got an answer outside that, you won't get the fourth mark. So looking at what I did, I got 186, and 186 is within that boundary, so I would get the mark.